Dear students, in this lecture we will be discussing about the determination of metacentric height. This metacentric height is associated with floating bodies. Floating bodies means the body which is partially submerged in the fluid. So we will also call it as partially submerged body. So here you can see a body which is partially submerged in the fluid. Some part of the body is within the fluid and some part of the body is above the fluid. Okay, and this blue line represents the water level. Blue line represents the water level. So here you can see in this floating body, let G represents the center of gravity. Center of buoyancy will be always below the center of gravity. Center of buoyancy is the center of the portion which is submerged in the fluid. Center of buoyancy is the center of the portion which is submerged in the fluid. So, in case of a floating body, the center of buoyancy will be always below the center of gravity. Okay, now we will see what is metacentric height. So, metacentric height is the distance from metacenter to center of gravity. So, we will use the symbol GM to represent metacentric height. So, it is a distance from metacenter to center of gravity. We will use the symbol GM to represent the metacentric height. Metacenter is the point about which the body will oscillate. The body will oscillate when we give a small, so metacenter is the point about which the body, a floating body will oscillate when we give a small tilt or moment. So when we consider a ship, in many cases there will be a possibility of oscillation of the ship when it is subjected to waves or wind and all. Okay, so this metacentric height is very much important in the stability analysis of the floating body. Ship is an example for a floating body. Okay, this oscillation is very common in case of floating bodies. Okay, so the floating bodies will be oscillating about a point, and that point is metacenter. And the distance from metacenter to center of gravity is the metacentric height GM. Okay, there are two methods to determine the metacentric height. One is analytical method and second one is experimental method. So first we will see the analytical method of determination of metacentric height. So let us consider the same floating body and I have drawn two different views of this floating body. So the first one shows the front view of the floating view. This front view is drawn here. It is an enlarged figure. And the second one is the plan view. It is the plan view about the water level. So here we have the water level. So when we cut this floating body along this water line and when we view from the top, we can see a figure like this. So this is the plan view about the water level. So this is the YY axis. And metacentric height GM is given by this equation I by V minus BG. I by V minus BG. So here I represents moment of inertia of plan of the floating body about the YY axis. So when we consider this figure, in the plan view we can see a rectangle. So the moment of inertia of this rectangle about the YY axis is given by I. And capital letter V represents volume of water displaced by the floating body. And BG is the distance from, it is the distance from center of buoyancy to center of gravity. Now we will see a numerical problem related to determination of metacentric height. So here we have a rectangular pontoon. Pontoon means a rectangular shaped floating body, okay, which is 5 meter long, 3 meter wide and 1.2 meter high. So the length is 5 meter, width is 3 meter and the total height is 1.2 meter. And depth of immersion of the pontoon in sea water is 0.8 meter. So the depth which is submerged in the sea water is 0.8 meter. So this depth is 0.8 meter. This depth is also 0.8. So I will draw the plan view and front view of the pontoon. This line represents the YY axis. And this is the water level. And depth of immersion is 0.8 meter. The total depth is 1.2 meter. And it is mentioned center of gravity is 0.6 meter above the bottom of the pontoon. So center of gravity G is 0.6 meter from the bottom of the pontoon, and we need to determine the metacentric height. Metacenter will be somewhere here. Metacenter will be somewhere above the body, and it is the point about which this pontoon will oscillate when we give a small tilt or a, and this is a plan view. So when we mark the dimensions at the plan view, this length will be 5 meter. This dimension will be 5 meter, and this dimension will be 3 meter. Okay, we need to find the metacentric. The metacentric height GM is equal to I by the volume displaced minus, let this point be A. Let the bottommost point of the pontoon be A. We know that AG, bottom of the pontoon to the center of gravity. So it is AG. We need to find AB. So BG will be equal to AG minus AB. We know that 0.8 meter of the pontoon is submerged in the fluid. So center of buoyancy is the center of the portion which is submerged in the fluid. So when we consider this figure, this much portion is submerged in the fluid. So center of buoyancy is the center of the portion which is submerged in the fluid. So center of buoyancy will be center of this portion. So this AB distance will be half of the depth of submergence, which is 0.4 meter. So AB will be equal to 0.4 meter, which is half of the depth of submergence. So BG will be AG minus AB. 0.6 minus 0.4, you will get it as 0.2 meter. That is BG. Now we need to find the volume displaced. Volume displaced is equal to the volume which is submerged. Submerged volume of the pontoon. So volume submerged will be equal to length into width into depth of submergence. Length is 5 meter, width is 3 meter, and depth of submergence is 0.8 meter. So we will get it as 12 meter cube as the volume of submergence, which is same as the displaced volume. We know I is the moment of inertia about YY axis. Since it is a rectangular pontoon, the equation to find the moment of inertia is 1 by 12 into D into BQ, which is equal to 1 by 12 into 5 into 3Q. You will get it as 45 by 4 meter cube. Now we can directly substitute in our equation. We have got all the parameters. GM will be I by V minus BG. So you will get it as 0.7375 meters as the metacentric height. So when GM is greater than 0, we can say the body is stable. The body is in stable equilibrium.